Okay, so for today, we're going to be looking at intercepts, both the x and the y intercept, and also um, the equation of y equals mx plus b. Some more work on that equation. So if you're given a graph, and it looks like this, pretend that that one went through that dot there. Can you tell me what the intercepts are? First off, what does the intercept mean? It means where the line crosses the axis. So we have our x-axis down here, this one here, and so where it crosses right there, which is at 4, if we're assuming that these are ones, so we can say that our x-intercept is equal to 4. And if we look up at the y-axis, this line is crossing there at 1, 2, 3, 4, 5. So our y-intercept is equal to 5. Okay, so we're just looking at where they cross the axis for this one, these ones. So if I have another line that looks like this, what's the x-intercept with this line? Where does it cross that x-axis?
4.
Crosses the y-axis at 4. So the y-intercept is 4. But what about the x-intercept?
Oh, wait, for which line?
This is my line right here. That's my drawn line.
Sorry. I thought we were looking at that first one still.
Oh, no. I'm sorry. Does it cross the x-axis at all?
No.
No, so there is no x-intercept. Because it's a horizontal line, it doesn't have an x-intercept. What about if we had a line that looked like this? This one now has an x-intercept at 6, but the y-intercept, there is none. So that's the vertical line. And then what about a line that looks like this? Remember, you're going x-intercept first, and that's at 1, a positive 1. And a y-intercept of negative 1. So your first few problems on your worksheets are going to be looking at your graphs and coming up with the x and y intercepts. Okay, doing that from graphs. Your second set of problems are going to be the y-intercepts from the equation y equals mx plus b. We want to make sure that anytime we're trying to get slopes or y-intercepts out of an equation, we're going to solve it first for y. We said yesterday we were solving it for y, and we looked at the number in front of that x, and we said, okay, that's an implied 1 there. So our slope was 1. This time, we're looking at what is that number and the sign right in front of it that's right after the x, that -3. That is the y-intercept. So we can pull out a slope and a y-intercept from that equation of that line, as long as the line is solved for y. So the second set of problems that you have is just given an equation like this, tell me what the y-intercept is.
2.
Thank you, Will. It is 2. We're just looking at this last part and saying, yes, the y-intercept is 2. So, hard yet? Looking at those graphs and pulling out the x and y-intercept, looking at the equations, pulling out the y-intercept.
Would the m in that equation be -2?
It would, yes.
Okay.
And then the last set of questions are, they give you equations that aren't in the y-intercept form. They're in standard form or some other form. And they want you to and because we're not interested right now in what the slope is, today's lesson isn't about slope, it's about intercepts. Because we aren't interested in the slope, we can find our intercepts a different way rather than solving for y, because that only gives us one of the intercepts. So if we want to find both of the intercepts, we are going to plug 0 into one variable, into each of the variables, but one at a time. So if I plug 0 in for x, and I rewrite this equation without that x in there, anything that you have 0 added onto, that just kind of disappears, right? So we're left with -3y equals -15. Now when we divide by -3, we get y equals a negative and a negative is a positive. 15 divided by 3 is 5. So we get our y-intercept to be 5. And we're going to go back up this time and plug in for y. So x minus 3 times 0 equals -15. -3 times 0, that just goes away. And we're left with x equals -15. So by knowing that x and y intercept, we can graph the equation. A y-intercept of 5 means I'm going up 5 units on the y-axis. An x-intercept of -15 means I'm going back 15 units. And there will be my, should I have negatives on them? There's my y-intercept, or my x-intercept of -15, my y-intercept of 5. And I can graph that
Will we
line.
have to graph it on the assignment?
Yes, you will. If you run out of room, like on the graph, they'll give you a standard graph. Just graph it as best you can. Let's look at another one of these. (2x plus 5y equals -10. I want to find the x and y intercepts and graph it afterwards. So I'm going to plug 0 in for x. So 2 times 0 plus 5y equals -10. This term cancels out. and divide by 5, and I get y equals -2. Do the same thing, but plug in the 0 for the y. That term goes away. I get 2x equals -10. Divide by 2, and x equals -5. So on my graph, -5 on the x-axis, -2 on the y-axis, and a line that connects them. Now, because I was fighting with the machine, my computer, I didn't do any problems like these that I'm going to show you, but we're going to look at them a little bit here. So if you're given the equation, we already kind of looked at this one, 2x plus 5 or minus 5. Pulling the information out of that form, this is your y-intercept. That's what we're concentrating on today, but you can also pull out the slope of what you did yesterday. So the slope is -2, the y-intercept is -5. So you can get both of those informations out of there. And then you can also create an equation of a line if you're given the slope and the y-intercept. And it's just a matter of plugging those into that equation. Y equals 2/3 x plus 5. So like I said, I didn't give you any practice on these for today. Today is mainly just focusing on intercepts, getting them from graphs, getting them from the y equals mx plus b, or I should say getting the y-intercept from that, and then the last part, getting the x and y intercepts from an equation that's in standard form, and then graphing it. Questions?